Okay, our next equation is 2x cubed minus 9x squared minus 108x plus 2. And to find the zeros for this equation, you're going to have to use synthetic division. Or I guess long division, if you want, I don't know. Either way, you're going to have to use synthetic division, and this has no rational zeros, so you're going to have to graph it to find them. I graphed it on my calculator. That's what it should look like. The x's that I got were negative 5.45, 9.93, and 0.02. Next, we're going to find the critical points, and they're just, like I said last time, where the derivative is equal to 0 or undefined. So, derive the equation, and that's what I got, 6x squared minus 18x minus 108. And to find the zeros, we're actually going to have to use the quadratic equation. So there's my work, and I got x equals 6 and x equals negative 3 as my critical points. Okay, to find the relative extremum, just going to plug in the critical points to the original equation. So I plugged in negative 3 for x in the original equation, so 2 times negative 3 cubed minus 9 times negative 3 squared minus 108 times negative 3 plus 2. And I got 191. And for the other one, 6, plugged in 6, I got... Sorry about that, someone walked in. I got negative 538. The biggest one is going to be the max, and the smallest one is going to be the min, or the minimum. So we got the max, relative max is going to be at the point negative 3, comma 191, and the relative minimum is going to be at the point 6, comma negative 538. To find the increasing and decreasing intervals, we're just going to set up sign line, which is a number line marking the critical points. We're going to test points in the intervals, so negative infinity to negative 3, negative 3 to 6, and 6 to infinity, or positive infinity. So for the negative infinity to negative 3, I plugged in the point negative 4, so we got 6 times negative 4 squared minus 18 times negative 4 minus 108, and I got 60. So since it's a positive number, it's increasing. For negative 3 to 6, the negative 3 to 6 interval, I plugged in the point 3. I got 6 times 3 squared minus 18 times 3 minus 108. I got negative 108, which is decreasing because it's negative. And for the final point, I plugged in 7. 6 times 7 squared minus 18 times 7 minus 108. I got 60 again. Since it's positive, it's increasing. To find the inflection points, the inflection points are where the derivative of the derivative equals 0, so, or doesn't exist. So we're just gonna derive the derivative and set it equal to 0. Since it isn't a fraction this time, we're not gonna be able to set it to undefined, because it's always going to equal something. So we're going to set it to equal to 0, and I got 1.5. Find concave up and concave down, just like the increasing decreasing intervals. Sorry, someone walked in again. Okay, just like the increasing decreasing intervals, we're just going to make a sign line for the second derivative and plug in points near the inflection points, which is only 1 this time, so we're only going to have to plug in 1 behind it and 1 in front of it. I used 0 and 2, so 12 times 0 minus 18, obviously negative 18. 12 times 2 minus 18, 6. So, oh crap. So it's going to be concave up, or negative 18 concave down, and 6 concave up.